So moving forward, let's consider the next one, that is question number 17. Let f from -1 to infinity to r be defined by f0 equals 1 and for rest of the values of domain as log 1 plus x upon x. Now then the function increasing, decreasing, etc. in the given interval, this is what we have to check about. Let's start. We have fx is equal to log 1 plus x upon x. Obviously x is not equal to 0 we are taking, because for 0 it is given to us as 1. Differentiating this function, we observe f dash x is equal to x upon 1 plus x minus log 1 plus x into 1, so not required to write 1, upon x square. Simplifying further, x minus 1 plus x into log 1 plus x divided by x square into 1 plus x. Now we can see that log 1 plus x, it is taking minus infinity to plus infinity all values. X in the interval -1 to infinity excluding 0, some positive values and some negative fractional values all taken. So we are not very sure whether this expression is positive or negative. In general, in such cases, two possibilities are there. One, we can plan graphically, like keep this 1 plus x here itself and plan the graph of this function as well as logarithmic function and see which is on the upper side, which is below, so that you can conclude whether it is positive absolutely or negative. Option 2, you can consider this problem figure as another function, say gx. Now let's talk about gx. Gx is equal to x minus 1 plus x log 1 plus x. Simple function. Now g dash x is equal to 1 minus this into its derivative, that is 1 itself, minus log 1 plus x. Now clearly when you talk about the interval -1 to 0, -1 to 0, you can see that this is a positive number because negative into negative becomes positive. So this is positive. And when x is greater than 0, what is going to happen? When you say x is greater than 0, this value is positive, so overall value is negative. So we have a conclusion that gx is increasing for the first interval and decreasing for the second interval. Therefore, gx is increasing on -1 to 0, that is gx is less than g0 for all x less than 0. Obviously, I am talking in this interval -1 to 0 only, correct? Because increasing function is there, so inequality is same. Now what is g0? When you put x is equal to 0 in this assumed gx, you can see it is 0, correct? So just write down gx is less than 0 for all x in the interval -1 to 0. Moving forward, gx is decreasing on 0 to infinity. Decreasing meaning inequality is reversed. Gx is less than g0 when x is greater than 0. Again put g0 as 0. So we observe gx is less than 0 for all x in the interval 0 to infinity. So what is the conclusion? Gx is negative throughout. And at 0, we know that it is 0. So here we can conclude at this stage, yes, this value is negative. This value is negative throughout. What is the conclusion over here? Look at the options. Increasing in -1 to infinity, no. Increasing and decreasing, no. Decreasing, increasing, again not. Yes, we obtained at the correct answer. It decreases in the interval -1 to infinity. So let's write down the correct answer for this question. I'm sure this interesting question is good one. Let's consider another one. If the equation cos 4 theta plus sin 4 theta plus lambda is equal to 0 has a non-zero solution for theta, then lambda lies in the interval. So what we actually require, we need to see the range for this function. Lambda is negative of this value, so whatever range you obtain for it, accordingly you can conclude for lambda. We know that cos 4 theta plus sin 4 theta, let's say we are starting solution here itself, is equal to 1 minus 2 sin square theta cos square theta, or 1 minus half sin square 2 theta. Now, the value of this expression is depending upon this one, correct? So yes, we can conclude here cos 4 theta plus sin 4 theta lies in the interval. The minimum value is obtained when it is maximum. Maximum value of sin square 2 theta is 1. So the minimum value of this expression is half. Moving forward, maximum for the expression will be obtained when this is minimum. Sin square function minimum value is 0. So the maximum is obtained is 1. Therefore, cos 4 theta plus sin 4 theta, which is minus lambda, therefore lambda belongs to minus 1 to minus half. Since this term is half to 1, lambda is negative of it, so lambda is minus 1 to minus half. So let's check out from the given options, and we can see option number 1 is the correct answer for this question. I'm sure this is clear. Time to take up question number 19. If a curve y equals fx passing through the point 1, 2 is the solution of the differential equation this one, then we can plan to change into linear, or we can also plan through inspection. Let's try. We can see this question as 2x square dy minus 2xy dx is equal to y square dx. Correct? Now, taking 2x common, we can write x dy minus y dx upon x square is equal to y square upon x square dx. So we can read it as d of y by x upon y by x whole square is equal to dx upon 2x, or we can keep 2 here itself. This is clear? All right. Moving forward, this is equal to minus 2 upon y by x, meaning taking reciprocal, 2x upon y with negative sign is equal to log x plus constant is c. This curve is passing through 1, 2. It is passing through 1, 2, meaning that we can get the value for c. Put here x as 1, y as 2. This is minus 1. This is 0. So c is minus 1. C is minus 1. So time to write the function again. Therefore, minus 2x upon y is equal to log x minus 1. Now what the question is talking about, let's check out. F half is being asked. Therefore, for f half, what is required? Put x is equal to half. Let's go for it. Minus 1, 2 into half is 1, upon y is equal to log half minus 1. We know log half can be written as minus log 2. Minus will be cancelled. Take reciprocal. This is y is equal to 1 upon 1 plus log 2. Time to check from the options. 1 upon 1 plus log 2, yes, it is available here as option number 1. So let's mark and mention as the required result. So I'm sure this question is also clear. Let's consider the next one.